Hi everybody, my name is Victoria. Today I'm going to be showing you how to solve mass-specific properties using the knowledge that we learned from thermodynamics ME300. So let's take a look at this example. So usually I like to start my problems with listing all the givens. So let's do that. Here we have a rigid tank that has a volume V equal to 0.0023 meter cubed. And it contains 1 mole of carbon dioxide. So N is equal to 1 mole. And it is maintained at a pressure of 1 megapascal. So P is equal to 1 megapascal. The molecular weight of carbon dioxide, squiggly M, is equal to 44 gram per mole. And the internal energy, the total internal energy, capitalized U, is equal to 19.37 kilojoule. Alright, so these are the givens, and we're asked to solve for the mass-specific volume and mass-specific enthalpy. So, what do you think these properties are? So I hope you got this right. So mass-specific volume is just the volume divided by mass, and mass-specific enthalpy is the enthalpy divided by the mass. So anything mass-specific, you just take the original property and divide that by the mass. So now let's start solving for these properties one by one. So the first one is the mass-specific volume, which is the volume divided by mass. We know the volume, which is 0.0023 meter cubed, but we don't know this mass. So what do you think is the best approach to solve for mass using all the givens? Yep, it is the amount of molecules N times the molecular weight, squiggly M. So here we have 1 mole times 44 grams per mole. And then we have the mass, which is 44 grams, or you can write as 0.044 kilograms. Now we can plug this mass back to this first equation. So the volume is 0.0023 meter cubed divided by the mass, which is 0.044 kilograms. And this gives us the mass-specific volume 0.052 meter cubed per kilogram. Since this is one of our final answers, I'm going to box this. Alright, now let's start solving for the mass-specific enthalpy, H, which is the enthalpy divided by the mass. This time we know the mass, which is 0.044 kilogram, but we don't know the enthalpy. However, we're given the internal energy. So how can you relate internal energy to enthalpy? So enthalpy is equal to the internal energy plus the product of pressure and volume. Since here we're dealing with specific properties, we're going to divide each term by m, by the mass. And this will give us the specific mass-specific enthalpy is equal to the internal energy and the mass plus the pressure times. So here, if you haven't noticed, the volume divided by mass, which is the mass-specific volume, is something that we already calculated. So that's the specific volume. Now we know everything that we need to calculate the mass-specific enthalpy. We know internal energy, 19.39 kilojoule, and the mass that we calculated from the first step, and we know the pressure, and we also know the mass-specific volume. So now let's plug and chug. So internal energy is 19.37 kilojoule, which is also 19,370 joule. divided by the mass, 0.044 kilogram, plus pressure, which is 1 megapascal. This is also equal to 10 to the 6th Pascal. Okay, so it's 10 to the 6th Pascal times the specific volume, which is 0.052 meter cubed per kg. So this will give us the mass specific enthalpy of 492,227 joule per kilogram. Alright, so this is our final answer for the mass specific enthalpy. Alright, I hope you found this helpful. Let me know if you have any questions.